All right, so this is a review from Chapter 3 of stoichiometry and the steps involved in solving just about every stoichiometry problem you come across. So step number 1 is to write the balanced chemical equation. Many times that's done for you, and so you don't have to do step number 1, but it's in there in case it's in words. You got to correctly write and balance the chemical equation. Step number 2, convert to moles. So when in doubt, convert to moles is usually how the saying goes. You usually need this device right here, the periodic table, because usually they'll give you grams, and then you're going to have to go from grams to moles. So keep track of that as you go and know what molar mass, stands for and how to add it up on the periodic table right here. When we get to Chapter 4, we'll show you another way to convert to moles, and it'll make it a little bit more difficult. Then step 2.5, this one you only do if there's more than one amount of a reactant is given to you. So you have to be a good reader, you have to be good looking, which you already are, and then you have to be good at looking at the problem, and you have to decide, is there enough information about 2 or more of the reactants? So take number 77, for example. This is one of your homework problems. It gives you that you have 1.85 moles of NaOH, not O, right here, and 1 mole of CO2 right here. So now you have information about 2 different substances. So now you have to do step 2.5 because one of them is going to limit the amount of stuff. And so to do that, you divide each by its coefficient. And so for this one, NaOH would be divided by 2 because there's a 2 in front of it, and the CO2 would be divided by 1 because there's a 1 in front of that. And you find out which one is the smallest. Once you've determined which one is the smallest, or if you didn't have to do step 2.5, then you go to what's called the mole to mole fraction, or mole to mole ratio. And that's a fraction that you put your desired unit on the top, what you desire to know on the top of the fraction, and you put the units that you possess, or the ones that you currently have. I don't know if possess has that many S's. The ones that you currently have in a position where it's going to cancel. Then step number 4, you sometimes have to do, sometimes you don't. You convert to the asked for units. And the asked for units might be grams, and so you're back here where you're going to go from moles to grams right here. It might ask you for atoms or molecules or ions, so you might have to go from moles to here. It might ask you for something else, but more than likely it's right here because those are the ones that you know how to convert to and from. All right, so I've taken these steps right here, and I put them on a little card. And then I just kind of keep this card handy, and you might want to do that as well. And then you can look and refer to this card every time that you try some of these problems. So here's my example problem, and I'm going to make it a limiting reactant one right away because they all kind of follow all the same steps. And I'm going to do a chemical equation right here of N2 plus H2 goes to NH3. And I'm going to ask 3 questions about it. Question number 1, I'm going to ask, first of all, which one is the limiter? And then step number 2, I'm going to ask how many grams of NH3 are produced. And then number 3, I'm going to ask how much of the excess reagent remains. So this is just a short way of writing the word excess, in case you've never seen that before. And then reagent just means one of the reactants. That's what reagents are. And then how much of it remains. And we'll ask in moles how much remains. All right, so some other data. Let's say we start here, this particular example problem, with 28 grams of N2. And let's say that they tell you that you have 2 moles of O2. All right, they give you that data in some scary, difficult to read story problem, and you've got to devise that. So now let's follow these stoichiometry steps right here, and let's see if we can go along and do all of those. And you'd follow these exact same steps whether it was a limiting reactant problem or not. So step number 1 is to balance the chemical equation. Well, we notice right now it's not balanced. So if I put a 3 here, now I've got 6 hydrogens. I put a 2 here, I've got 6 hydrogens. I've got 2 nitrogens and 2 nitrogens. Now it's balanced. So I'm going to assume you're okay at balancing chemical equations. If not, then you've got to spend a little bit of extra time writing the balanced equation each time. Step number 2, when in doubt, convert to moles. And I'm given 2 amounts of substances, so I'm going to have to convert both to moles. So 28 grams of N2, put a multiply sign, put a line. And then, oh, look, lo and behold, I'm already given the number of moles of this one, so that's going to be easy. So I'm given 2 moles of H2. Organize your data really nice on the left-hand side of the page. Put your multiply sign, put a line, skip a line between each one. Make it really nice and neat and organized, and then it makes it really easy to figure things out. So we're going to go from grams to moles right here, and we're going to need the periodic table to do it. 1 mole goes on the top, molar mass goes on the bottom. If I look at nitrogen on the periodic table, it's 14, and it's N2, so 14 times 2 is, oh, that's 28. So 28 grams goes in a position where it's going to cancel. 1 mole of N2, whoops, N2 is my new set of units. 28 divided by 28 is 1, so I'll have 1 mole of N2. So I have 1 mole of N2 and 2 moles of H2. I'm done with step 2, convert to moles. All right, now we're on to step 3, divide by the coefficient to determine the limiter. So N2, I'm going to have to divide that by 1. H2, I'm going to have to divide that by 3. Now, I don't actually have to do the math. You can. 1 divided by 1 is easy. That's 1. But, you know, if it's some weird number, like 3 times 10 to the negative 5th, then, you know, you don't really want to divide that by 6 or something like that. You don't have to. But what you do have to do is decide which one of these, after I do the math, is going to be the smallest. So, is 1 divided by 1? That's going to be 1. And 2 divided by 3, well, that's going to be 2/3. Which one is smaller? Well, the smaller one is obviously the 2/3. And so that, right there, folks, is my limiting reagent. And so H2 is the answer to my first question because it is the smaller one when I divide by the coefficient. So H2 is the limiter. I answered question number 1. Now I'm going to slide this over here so then you can still see it. But I'm going to go on and I'm going to work question number 2 right over here on this page. Question number 2 says, how many grams of NH3 can be produced? So I'm still at number 2.5 right here, and that's really important because anytime I go on to 3 or 4, I need my answer to number 2.5. I use the amount of H2, or the amount of the limiter, and I always start with that for any other question. So 2 moles of H2, I put that down first. Then I put a multiply sign, put a line. And then I take my moles of my substance that I already possess or already have, and I put that in a position where it's going to cancel. So moles of H2 down here. And then I put my moles of my desired substance on the top. So this is step 3, mole-to-mole ratio, mole-to-mole fraction. I desire to know the amount of NH3 that's produced. I know it says the word grams, but we're not going to get there until step 4 right down here. So I need to do the moles of NH3 first. NH3, by the way, is called ammonia. So I'm looking at how many moles of ammonia can be produced. Now the numbers I get from the balanced chemical equation. So I put a 2 here from NH3. H2 has a 3 right here. So that's my fraction. Lastly, I look to see if they have some asked for units. What do they ask for? Well, they ask for grams. It's right there right at the start. So I'm going to have to do step 4. I'm just going to go from here to moles to grams. And going from moles right here to grams means molar mass on the top, 1 mole on the bottom. So I'm going to put moles of NH3 in a position where it's going to cancel. I'll put grams of NH3 up here on the top. And in 1 mole, add up 1 nitrogen and 3 hydrogens on the periodic table. That's 17. Now let's try it on your calculator. Please try it with me and see how you do. 2 times 2. Enter, divided by 3, enter, times 17, enter. Did I do it right? I got 22.6 to the number of sig figs. I'm only giving 1 sig fig, but let's just go to 3 just to make it easy. 22.7 grams would be produced. That'd be my answer to number 2. All right, any questions so far? All right, last question then. How much of the excess reagent remains? This is usually the question that separates the A's from the B pluses, because this is a tough question. Step number 3, remember what I said, when you're working past number 2, no matter how many questions they ask, always start with the number of moles that's your limiter. Always start with your number of moles that's your limiter. So 2 moles of H2. Notice it's not the number after I've divided it by the coefficient. It's the number that you started with. So write yourself a little note. Start with limiter. And the total amount, not the amount after I divided by the coefficient. Put a multiply sign, put a line. And now we're going to do a comparison, or a mole-to-mole ratio, between nitrogen, so the units that I have, or the units that I possess right here, and my excess reagent, my thing that I have too much of. Well, there's only one other thing that I have too much of, and that's the nitrogen, right? Because I figured out that there was going to be excess of that, because that was not the smallest when I divided by the coefficient. So, whoa, I made a mistake here. Should be an H2 right here. Oh my goodness, right here, limiter, H2. This should be an H2. My bad, my bad. Okay, and then let's see, I want to put the excess reagent up here, which is the nitrogen, so I put moles of nitrogen up here on the top. All right, this is step number 3, so I have to look at the balanced chemical equation to find the numbers. Maybe you want to write yourself a little note up here first and put the excess reagent goes here. And this is the one that I have. This is my limiter. Whatever is written over here, that goes right here. Okay, going back to the equation now, nitrogen has a 1 in front of it. Hydrogen has a 3 in front of it. And since it's asking how many moles of the reagent remain, I'm going to stop right there, because now I have my moles of N2 that I used. Because this is how much that's going to be used when all the hydrogen's used up. 2 times 1 is 2. 2 divided by 3 is 2/3. So 2/3 of a mole, or 0.66666, is used up. Trickiest part right now, because it's not on this sheet. This is how much is used. This is how much I have to start with. I have this to start with. This is how much I use. How do I find the difference between those two? Hopefully you said subtract. So 1 minus 2/3 equals 1/3, or 0.3333, and this is my moles of N2 that are left over. Now they might ask you, what are the grams that remain? You just have to convert from grams to moles and do that part. But this subtracting, that's the hardest part for a lot of kids to get. All right, post it up or unmute your microphone. Questions about stoichiometry steps, about limiting reactant problems, about doing all those pieces. Homework problems, 77. Start on a new page. Make it neat, make it organized, make it big, write large. Sodium hydroxide reacts with carbon dioxide as follows. Which is the limiting reactant? Ooh, limiting reactant question right away. Then it says how many moles can be produced and how many moles of the excess remain after the reaction completed. Wow, that's just like the example one that we did. All right, let's get it started though. Step number 1 in all of these kinds of problems, write the balanced chemical equation. Okay, we have the balanced chemical equation. 2 NaO plus CO2 arrow, and then NaCO right here, not nacho. Don't confuse it with nacho cheese. That's cheese that's not your own, in case you didn't know that. Okay, so then there is the balanced chemical equation. That step is done. Then step number 2, convert to moles. Oh, that's done for us already. Way on the left-hand side right here, 1.85 moles of NaO. Skip a line, 1 mole of CO2. All right, we got step number 2 down. Step 2.5, divide by the coefficient. All right, you try it. Divide by the coefficient. Which one ends up being smaller? Okay, so NaO divided by 2 and CO2 divided by 1. So 1.85 divided by 2 is going to be smaller, so this one ends up being my limiter. All right, I can come back. Well, let's see. Let's just set you up for the second question. So now that I've determined my limiter, how many moles of Na2CO3 can be produced? Start with your limiter. Always start with your limiter. That amount, not the amount after you divide it by the coefficient, but start with the amount. And then put the units that you have in a position where it's going to cancel. Put your desired units on the top. What do they want you to know? All right, you're going to have to figure that out from there, but they desire you to know this guy right here. And then the last part, toughest part, how many moles of the excess reactant remain? Well, start with your limiter again. But this time when you do the fraction or you do the comparison, make sure to compare it with the excess reagent. That's this guy right here, so put that up there. All right, that'll get you started on 77. Any other questions on 77? All right, go to another page or give yourself lots and lots of room. Let's go to 78. Aluminum hydroxide reacts with the sulfuric acid as follows. Balanced chemical equation. Done for us already. We don't even have to write it down. It's given to us. Nice. Step number 2, which is the limiter. Ooh, we've got moles and moles, so it's going to be the limiter again. You're going to have to divide by the coefficient to see which one's the smallest. And then how many moles of this can form under these conditions, and how many moles of the excess remain at the end. So 0.5 moles. AlOH3, and then 0.5 moles of the Al2SO4 divided by the coefficient. This one's a 2. This one is a, whoops, I wrote this wrong. 0.5 moles of H2SO4. Sorry, I was looking ahead. H2SO4 is a 3. Now you can tell which one's going to be the smallest, right? If you can't, try it on your calculator. That's okay. But then remember that the smallest one is going to be your limiter, and then use your limiter for the next 2 parts. I'm going to leave that rest of number 78 for you to do. Leave a whole page. Lots of room needed for these. Spread them out. Big, neat, large, and organized. All right, and then I'm going to go on to 79, and I'm going to set that one up for you. Help you with that one. And this one is an Alka-Seltzer Fizz tablet dissolved in water. And then it gives us a balanced chemical equation. So step number 1's done for us. Balanced chemical equation, all done. Step number 2, 1 gram of sodium bicarbonate, 1 gram of citric acid are allowed to react. Then it says, which is the limiter? How many grams of carbon dioxide form? Ooh, same kind of question. And then how many grams of the excess remain? Oh, yeah, tough one. So step number 2, convert to moles. Now we have 1 gram of the citric acid, the H3C6H5O7, skip a line, and 1 gram of the sodium bicarbonate. You're going to have to add those up on the periodic table and go from grams to moles. Okay? So that's step number 2. Is to do the convert to moles. Once you've got them converted to moles, then you can do step number 2.5 and divide by the coefficient. So now you can look over here and find out, oh, this is a coefficient of 1, this is a coefficient of 3. Okay, remember you have to convert to moles first before you can do the divide by the coefficient. Once you've done that, you can find the smallest, that's your limiter. And then you can do part B and part C because you use your limiter in moles and then do the mole to mole ratio. Put the moles of what you have down here and then put the moles of your desired species up here. And do that in B. And you do that in C. Just remember in C your desired species is going to be your excess reagent. And then you have to subtract it from the amount that you started with, whichever one is the excess. tricky at the end, though. They want you to convert to the asked for units, and they're going to want you to convert to grams at the very end. All right. I'll take any questions you have right now. Otherwise, I'm going to push stop on the video, and then I'll stay on, and I'll take more questions from people for the next few minutes. But if you have some for the group, or if you have individual ones you want to post up in the chat and have me answer, sometimes that's super valuable for everyone.